Welcome back, everybody. Thanks for joining. Please feel free to come sit down close to the front as you come in. Get as close as you want to, or maybe even a little bit closer than you want to. All the way down front, please. Welcome back. Hope you enjoyed your lunch. I hope you've hydrated. It's cooled down a little bit. Hopefully it's more comfortable in here for everybody. Yeah, keep coming in. We are going to begin the first session of the afternoon talks. And we aren't, I will say. Justin and Jaya Shankar will be discussing advancing semiconductor industries in emerging markets. And I'm going to turn it over to them because I know nothing about that. So big round of applause for Justin and Jaya Shankar, please. Thank you very much.
Checking whether mic works. Thank you.
All right, good afternoon. Well, I hope you guys have a fantastic lunch, and normally lunch will send you off to sleep, but bear with us. This topic, might not be the best or most interesting topic, but it's definitely going to keep you on the toes, right? So today, thank you very much. My name is Justin. I'm currently the chairman for CST and Gidu College. And because of both the Engineering and Business College, today we have with us Jayashankar, and he's from Cadence. And I would like first and foremost for him to introduce himself and Cadence as a company. So this is going to be interesting. So why this is important? Why do we have Jayashankar here with us? Is because what if tomorrow we have an industry in Bhutan that deals with semiconductors, with integrated circuits, and we have an industry to support technologies that could actually now help out with things that we are all loving and doing. For example, FAB23, everything that you deal in with this space has to do with something that came from a company called Cadence. So, Jaya, don't mind.
Thank you, Justin. It's a pleasure to be here. Like Justin said, my name is Jay Shankar. I represent a company called Cadence. And before I start, I want to understand in the audience, how many of you understand what a semiconductor is? It's just a basic question. A show of hands, please. All right, great. Thank you. So let me then start, because the number I saw is less than half the room. So I'm going to start with a little basics about what we do as a company and the industry. As you know, there is a lot of electronics that's permeated into our lives. In fact, one can argue that you cannot go through a day without encountering electronics in pretty much everything that you do, right? And in that context, there are about 5 big waves that are happening in the world, right? The amount of compute that is available is increasing rapidly, right? So in your data centers and things of that nature. Things that are traditionally mechanical, like your automotive, like your cars and your two-wheelers, all of them are becoming more of electronic devices than mechanical devices. Things that affect our own well-being, medical, education, all of them are being driven to great heights using electronics and everything else that it brings along. Data, video, right, all those kind of things. In addition to all of these things, there are the things like artificial intelligence, where new answers to known questions are being created by something other than a human brain. All right. Now, all of this is the purview of what we from the semiconductor industry work on. And what do? We are the foundation and the building block on which every one of these platforms are built, right? So whether it is an integrated circuit, which goes onto a printed circuit board, which goes into a box, right, which eventually sits on your desktop, or it sits in your car, or is inside your car, all that is electronics. And the semiconductor and the printed circuit board requires that an engineer design them And Cadence provides the infrastructure for that design. So we are an electronic design automation company, and we provide tools, both software and hardware, tools for our engineers to design these wonderful end products that you have in your hands, that you have in your cars, that you have in your homes. Cadence Design Systems is a worldwide conglomerate. We have 26 offices across the globe. We are headquartered in a place called San Jose in California, which is north of San Francisco. We have the nearest office from here is in India. We have 4 offices there. I personally work out of the Bangalore office, which is in the south of that country. I run the business arm of Cadence in this region. Right, that's my introduction. I've been in this industry for 29 years now, entering my 30th year in the next month. I have seen the industry grow across the globe. I've seen industry grow in specific countries, Bangladesh, Sri Lanka, India, Pakistan, hopefully in Bhutan in the near future. I've also been a keen student of the dynamics of growth, which I think has led Justin to invite me into this discussion. Right? I don't know if I did justice to the question that you asked, Justin, but long-winded, but that is the introduction of Jaishankar, Cadence, and the semiconductor industry.
Thank you, Jaya. So you mentioned earlier on about Bangladesh, Sri Lanka, and all these countries. So having 4 offices in India, obviously there is a demand in South Asia. So, and if this demand is real, okay, and which means that countries like Sri Lanka, Bangladesh, and Pakistan, and many other countries around this area will require to start from ground zero. How does Cadence help these countries start from nothing to something?
So there are 3 building blocks, right? And I'm going at it from the level of importance of that building block and not necessarily the level of difficulty, all right? The first building block is availability of credible manpower, which means that you have to have engineers who have done credible work in this industry for any further investment to happen. And that investment could be foreign investment or could be just indigenous investment, doesn't matter. But there has to be a critical mass of engineers for this for an industry to take off, right? So in that aspect, Cadence provides a lot of assistance to countries at a governmental level, at a educational academy level, as well as an industry level, right? So at the government level, we have programs that we have with governments where there is a 7-year, 8-year plan that we can define for training people and then making them available to our customers or the semiconductor companies worldwide. At the academia level, we have the Cadence Academic Program, and which is part of our Cadence Academic Network, that allows universities to get those people trained up and make them world-class engineers. At an industry level, we help a lot of countries set up incubators, idea incubators, startup incubators, and so on and so forth. So that's the first pillar, manpower. Right? The second pillar is actually policy, right? What, with respect to when a country looks at this as a new industry, what is it willing to do as policy? So if you look at organic growth, it's slightly late in the cycle for Bhutan to think about organic growth, primarily because there are other ecosystems that are developing and have developed very rapidly. So a policy framework around how will we invite the foreign investments and what are the things that we can do to make their entry into the country and their stay in the country more comfortable and more profitable is the second primary aspect. The third aspect is also a vertical focused drive from an industry, right? There are some things which are specific to Bhutan that can be done. And in our earlier conversation, you were saying things that, you can take an electrical vehicle from, which is available in the worldwide market, but what is required here might not be exactly the same, right? So there might be things that you can do with existing technology right, which is available as know-how and that you can get without having to develop it from scratch, but then can be tuned, right? And that is the low-hanging fruit for the industry to start off. So industry, government policy, and manpower. I think those are the three primary pillars that one looks at when countries like Bhutan or Bangladesh or Pakistan or Sri Lanka or India want to start an industry.
So I'll touch base on the first point, manpower. So manpower, talent. So these are very key points which I think a lot of the youth over here will be, concerned about. Am I the right manpower? Am I the right talent? Do I have the right skill set to actually join this industry? Is Bhutan too late to join this industry? Am I too late to actually pursue this as a career? So can you?
Absolutely not. Absolutely not. Right. The industry is growing in the high single digits. We are already close to a $4 trillion industry, electronics wise. And going forward, the use models will keep innovating. The amount of electronics in your lives will keep increasing. So the demand for designing those new things is only going to go up. It is almost never going to go down. So if you think about a graph which is up and to the right as the demand, let us look at what the supply is at this time in 2023. It is our estimate that this region, which is Southeast Asia, requires close to 100,000 VLSI engineers today, right? Now, if you think about a growth vector, and those 100,000 engineers, by the way, are not yet available. So we're struggling to figure out how to make them available. So if you are a young aspirant looking to enter the semiconductor industry, there has never been a better time than now for this. And the 5 waves that I spoke to you about earlier, which is the data center, the automotive, the artificial intelligence, and those kind of things, are the reason why. We have always had some wave or the other driving the industry up, always, right? Whether it was the PC revolution or the handheld revolution, there was always something right. This is the only time in our history where there are 5 big market movers happening at the same time, right? There were 2022 and 2021 and 2022 have seen tremendous shortage of semiconductors. I don't know whether you're familiar with it, but people had to redo their designs because semiconductors were not available. It is that high demand. Right? So absolutely the right time if you are an aspirant into this industry. There is a whole paradigm of design that we are still to do, which all of you can be a part of eventually.
So just to add on, in front of us, there's a lot of youth here, okay? And a lot of you are probably thinking like, if this career would be suitable for me, what are the next steps? And being neighbors to a big giant called India, will we have the fighting chance? Because obviously India produces millions, close to at least 1 million graduates per year. And that's far larger than the population of Bhutan. So will I have a fighting chance to join this industry? Will the job market in India be available for us? Will we be able to receive training somewhere else and perhaps, grow our own industries in the future?
A few things have to happen for that. So let me just step back a bit and talk about what are the enablers for something of that nature, right? First, of course, there has to be an opportunity and a possibility for you to go into India, which I believe from a Bhutan and India perspective, because of the bilateral relationships, there is no issue, right? You can go and work there. So that's good. The second aspect is the timing of it. Right now, the government of India has published policy to train people the number of people that are required by 2026 is 85,000 people, engineers in this space, both at the bachelor's level, at the master's level, as well as the PhD level. So the question is, can we get the manpower in Bhutan up to speed to fill that demand, right? Now, assuming that it is not 2026 and it is 2028, all these things take time. So then the challenge becomes for Bhutan, for the next 5 years, are we able to get a critical mass of engineers so that the companies who have, facilities in India can actually come here and recruit? That is the question. The question is about timing and how fast we can get to critical mass.
So I think semiconductor is no-brainer to everyone. Everyone in this room owns something that has the requirements for it. But how big is this market really? You know, I mean, if we are to put into a dollar sense, you know, how big is the South Asian market for semiconductors, for integrated circuits? And if I were to be an engineer, if I were to go into this, pursuing this as a career, what kind of salary packages are we even looking at, you know, as a potential? Because those are very key driving metrics to, you know, have someone interested in a particular profession.
So I will come at it from data that is very recent from India, and we can extrapolate that to the region. The amount of semiconductors consumed in India is right now $101 billion a year, $101 billion, right? So that's a very large amount of semiconductors, and if you multiply that with a factor for the rest of it, we are talking in the $250 billion range. With respect,
And we are talking about USD.
USD, yes, yes, USD, right? So it's a very large consumer footprint, right? If I may use that word. So there are opportunities. The reason why there are opportunities is also that, because it's a very large consumer and there's a lot of demand. Packages, I mean, I don't know how one would define that, but typically, and I'm going to say this in lakh rupees. Is that okay? Okay. For a beginner to expect about what is the number? 1.2 million rupees a year is table stakes. Is very easy to do, right? And when you get to the 10-year mark, your salary should be in the VLSI space, and I'm not talking about IT or software here. In the VLSI space, when you approach the 10-year mark, you should be in the 1 crore rupees range. I don't know whether that translates lakhs and rupees. Does it translate?
Yeah, I think everyone here should be familiar with, naturally, Indian rupees and neutrons are very similar, you know, so I think everyone do understand the conversion here. So I think semiconductors has a lot of room. Okay, I think as a country, Bhutan itself, you know, with ample power, with obviously in the future with the right kind of skill set, we could be looking at an industry, a semiconductor industry within this country, and attract, you know, the top players to invest into a country like Bhutan. Of course, that requires a gestation period, you know, a lot of planning. Of course, manpower and talents are required. And this is definitely not an easy journey. But with all this, you know, in mind, you know, having that pragmatic approach to it, what do you suggest that a country like Bhutan should do? You know, preparing the manpower side, the education. Who do you think that we can, you know, reach out to actually fast track this kind of approaches?
Like I said, right? I think the first instance is to make sure that the people are available, right? And then, you know, always we speak about brain drain and people going out of the country and working in other places, right? In this specific case, it might not be a bad idea, right? Because one of the primary things that are required is the credibility of that engineer. So if you did have a trained engineer and that engineer went to an Australia or a Japan or North America or India and made a name for herself, and that credibility can then be transferred to the engineering graduates in Bhutan just because of that relationship, right? I think that's the first step that needs to get done. There are ways of fast tracking the credibility by attaching commercial work to the actual trainings that happen in universities and having that commercial work be technically sponsored by semiconductor companies from the worldwide pool that is available to us. So as a strategy, if you would ask me, Bhutan should employ two things. One is make sure the number of people who are trained are increased, and if that means to sponsor more students to go out and study, right, come to India and study, for example, or whatever that strategy might be. In the near term, if you can increase the current output of 120 to, let's say, 300 a year, I think that says something. That's one first thing. The second is that, there is already a diaspora of Bhutanese worldwide. We need to see if any of them are in semiconductor adjacent or semiconductor jobs, right? And they can be leveraged for credibility. And the third aspect is, of course, once you do have the manpower, how do you get them deployed? And in that case, Cadence can help quite a bit with respect to internships and opportunities to work with our semiconductor customers as interns or in starting positions.
So semiconductors, IC, integrated circuits, and a lot of these technologies are not new. It has been around for a very long time. And one of the key questions that I have is, where do you see this technology as at the moment? In terms of where we are on the S curve. Are there room for innovation? Are there things that someone that's pursuing this as a as a program, as a career, could actually still have room for innovation? Is it due for a pivot? What is your opinions on that?
It's a very, very good and interesting question. I'm going to answer it with some technical terms, and I'm going to use this term nanometer. And the numbers that I'm going to say before I say nanometer is the distance between one transistor and the other inside of the actual silicon. All right. So the current state of the art is 3 nanometer. All right. However, the cost of doing a 3 nanometer design versus a 28 nanometer design, which was state of the art just 2 years ago, or maybe 5 years ago, just before Corona, the state of the art was 28 nanometer. The cost difference between doing a design in a 28 nanometer fabrication unit, getting it fabricated in a 28 nanometer unit and a 3 nanometer unit is 5x, is 5 times, right? And the advantages of doing that, the reason one does that is because it gives you a design at much lower power. It packs a lot more functionality into the same amount of space because the transistors are much closer to each other. So the advantages it gives you of higher functionality in the same real estate of silicon and the speeds and the power at which it operates kind of is a diminishing return calculation. So coming back to your question about where is the industry headed? The industry is headed towards 2 nanometer, experiments are going on, and probably 1 nanometer, right? So that's on the scaling side. However, you will see progressively only specific aspects of your design, of your product, which benefit from that speed and that level of functionality will go to those higher nodes. So by extension, everything else will then be designed at the 28 and the 45 and 65 nanometer nodes. That creates a market that is very new to everybody in the world, which is an opportunity for all of us, because everybody is learning. And that is the 3-dimensional IC, 3D IC. What that does is it takes parts of the product, manufactures it in different nodes, and stacks it together in a 3D form to make an end chip or integrated circuit. So the 3D IC is the future, right? 3D IC is the future just because of the economics of it. And 3D IC is new. Everybody is learning. Everybody in the world is learning. How, if you say I'm a 40-year experienced person who has worked since the inception of the first semiconductor, at Fairchild Semiconductor, still does not know what the challenges in 3D IC. So new things. So that's a point of inflection, if you think about it. Gives us all a level playing field to compete on the worldwide scene. So that's what we have been promoting in this region, right? We speak about this. Our CEO speaks about this every opportunity he gets, particularly in India, right? So it's an inflection point.
I think this is exciting. If you would have, an advice to someone that's starting out in this industry, they have questions, they're curious about it. How would you make someone interested in this industry? Because I think obviously the youth today are inspired by the digital directions of where technology is going into. A lot of them are going to software. They are going to all the sexy bits, and they are unaware that this topic could be sexy. So how do you make them, feel that this topic by itself is sexy?
Okay. I wish I brought a presentation with me. I'll give you two examples, right? I'll get to the more exciting one second. But first, like I said, we are a San Jose, California-based company. And one of the American football teams, the 49ers, have their stadium in that town of San Jose, right? Now, you would think, okay, sports, semiconductors, what is the connection? The techniques that we use to cool the electronics in your laptop, in your handhelds, is very relevant for the same problem when a stadium is packed with people, right? What kind of air conditioning do you need? What are they? How does the air circulate and things like that? So we have a very close partnership with that team, the 49ers, to do something like that, right? The second example is we are a close partner to McLaren. Any F1 fans here? No? Of course, McLaren, right? And what we do for them is use our technology to figure out what is the airflow on their car, right? And try and reduce 2 microseconds of their lap time, right? So if you look at electronics engineering, and the people who are in the college right now will understand the op-amps and everything, you feel bored, but then the applications of that are so wide and so interesting that, what you can do with what you learn in electronics is just up to you today, right? And I can give you examples in the medical field, I can give you examples in the education field, I can give you examples in the agriculture field, where you take that knowledge of electronics engineering and semiconductor engineering and apply it to problems that are either to being traditionally solved with something else.
That is very interesting. I mean, 2 milliseconds in racing is a lot of time. And likewise, two nanometers in the IC space, is a lot. It's a big gap. So all these minute little numbers, might not seem a lot to everybody, but it does play a big part, in our daily life. It's just like you start improving your speed at work, your the way you do your work, just by 1 second every day. That full, accumulation of time is a big factor. So I hope everyone, really look into this aspect quite a fair bit more. But I think, do we still have time? How much more time do we have? Half an hour? Okay, we'll go into Q&A very shortly, but I just want to dive into the next portion, which is governments. How governments are receptive to, technologies like this, because obviously it involves huge investments. And it's not just having the dollars behind backing it to allow such an industry to happen within a country. You need many other supports. But how do you tackle the
is critical. So that's the strategic electronics part of it. And I think from a governmental view of what they should be thinking about with respect to semiconductors and electronics, I think that is the primary thing. Because at the end of the day, when you buy a silicon chip and put it into, let's say, a network router, you really don't know what the chip is doing, right? There have been instances, and I'm not going to name countries, but there have been instances where packets of information from defense labs were shipped out of that country into another country, which was the supplier of that box, right? Now, one can imagine the level of breach that creates. So from a government point of view, strategic electronics and what you do to safeguard what you build here, what you transact here, the information that is moved here is critical. That's number one from a government point of view. The second is on a policy framework point of view, right? You need to have a fairly welcoming way, a way of welcoming foreign investment, which includes not only infrastructure availability, availability of power, water, and those kind of things, but also manpower. But all of that has to come together. So that's on the policy side. The third aspect is what you asked about heavy investments, right? So most of the governments across the globe have now figured out that they have to be able to sponsor specific activity that they have 100% control of. If you look at the CHIPS Act in the United States of America, or the similar act in the European countries, large amounts of money have been earmarked for activities around semiconductors. $54 billion is the amount earmarked by United States of America for the CHIPS Act. And their primary aspect is everything in the digital economy, everything in their strategic electronics should be built, should be designed and built within the country of United States. Same thing with European countries. India has announced in December of 2021 a $10 billion package to do these kind of things. So investment-wise, I think every government is waking up to the reality that there are some things. I mean, we are a global village, yes. I don't need to have everything done within the country for everything that I need. True. But there are some things that require to be done here and kept here. That realization is coming through for a lot of governments. So to summarize, on a governmental front, I think all the three aspects, both strategic electronics, the policy framework, as well as investments, right, are critical.
Today we are at the event called FAB23. So FAB23 is an event where many like-minded makers, fab fabricators, and technologies will come together, working in environments and using equipments that are now able to accelerate a lot of this design thinking, thought processes, and turning it from an idea into a product, even at prototype level. How can Cadence contribute on this kind of environment, this kind of arenas, platforms? How can Cadence now put in take a stab at it, and then just perhaps in the future, fab lab environments will look different. How can Cadence contribute to that?
So I think anything that has an electronics content, particularly if it is designed as a first generation, then we obviously, because we are a design automation company at the core of everything, we can help. The other thing that we can do is if, some of these blocks are reusable in the sense some of, let's say, an interface, for example, has no secret sauce. There's no design intent in some parts of an electronics design. So you can buy the intellectual property from us. You don't have to build it from scratch. So your time to market can be drastically reduced by using IP blocks from Cadence. So there are multiple things that we can contribute in. But what I think is the biggest advantage of having a lab like this, or what I've seen here, is the mindset is that of an end product, right? Which is very difficult to get to if from a design point of view, because sometimes the end goal in our minds become the design itself, whereas the end goal should be the end product, not what you're building, right? It should actually do the things that you want it to do, hook or crook, right? And I think that mindset is very, very interesting, and I congratulate the conveners of this fantastic symposium, and be able to bring all of this together in a conference like this and able to ideate together. I think it's fantastic, and we would love to help if we can.
So I think I would love to see in the future where Cadence have the involvement in this kind of activities in Fab Labs, in FAB23, and the technology, the knowledge transfer could be something is part of it. I think a lot of the people here, especially technologies, have skipped that portion, and rely on a vendor to supply that part of the technology. And if we were to look at it, as a technology that we want to control, a product that we want to control, maybe Cadence is a partner that we want to keep working very closely to help proprietarize the kind of product that we want. And that might be the secret recipe. That might be actually the product that you guys might want to look into as the future end goal. It is a stepping stone. It is definitely something that it's a longer process, because in your mind, everyone will be thinking we don't have the expertise to do that. But and neither do we want to invest in that kind of capabilities. But maybe we should look into it, because there are real value. I think that kind of real value can contribute a long way. So looking at this today, we really do have a lot of exciting things that is coming out from this space of software in terms of electronics, electrical, the semiconductors, in its integrated circuits, and it would drive how we look into a product, how we look and vision the final product to look like, and where we can, actually bring value to it. More importantly, I think all these assistance is just like what we are doing in Fab Lab. We have equipments to help us produce things that we want to produce and bring value to society and to create a system around it. But I think a lot of times people don't understand where to reach out to. I believe if we were to build a better Fab Lab, okay, what is a better Fab Lab? A better Fab Lab will be equipments that can do things that we currently can't do. Okay, and that is probably what we don't know. Okay, and we have to expand our horizon to actually go into these areas, and therefore we are able to utilize it as tools to help with our daily lives and to enrich us in a further aspects. Jaya, thank you very much. I would like to now spin this off to the audience for Q&A. If there's any questions, please feel free. We are here to answer any of the questions.
Hi, I'm Dr. Kiran. I'm from India. My question is about advanced materials used for semiconductors. I mean, right now, when you speak about the $101 billion market for semiconductors, VLSI, or the $54 billion market in the USA that is earmarked under CHIPS Act, everything, is that only for development of products in VLSI in semiconductor areas with existing materials, or is it also for research in these areas? And do governments actually have something earmarked for advanced level research in these areas, particularly given that we are moving towards flexible and even edible electronics?
So about $500 million out of the $54 billion is earmarked specifically for research and training in the US. In India, we have already rolled out two programs. One is National Policy on Electronics 2019, that has specific funds for research and development, and that includes materials. And the recent $10 billion announcement, 2021, has $500 million that has already been spent for GaN, right? Gallium nitrate. So silicon is one substrate, gallium nitrate is another. So gallium nitrate research, which is going to happen in the semiconductor complex in Chandigarh. So answer to your question is yes. We cannot move forward without having material research. For example, we have always done semiconductor design in a particular way. Now we are doing inductors on semiconductors, and the inductors on semiconductors now allows us to put digital as well as RF circuits in the same silicon, right? So those kind of innovations have to happen, and there's a lot of money and work that's happening.
If you don't mind, I can ask you another question, if that's okay. So all these 3-5 materials being used for semiconductors has been under research for more than like 2 decades now. Gallium nitride or indium pentium or indium oxide, all these have been under research for a long time. But why is it that it's taking so long for the industry to actually lap it up and make devices with these materials as such?
It is 2 things, of course. One is the fact that there's a lot of investment already in the CMOS, right? And therefore, it's easier to move that node further than bring in a completely new technology. Number 2, it has always been specialized applications, whether it is high voltage or RF or those kind of applications which absolutely require this the new material that it has been used for. It will continue that way. I don't see it changing. But the only thing is, in the scheme of the 3D IC, right, it makes a lot more sense because you're not restricted to have all of the real estate as silicon, right? You can have a gallium nitride also because you're stacking dice.
Question.
Actually, the most of the words that Mr. Jess said just went through my head. with a little bit of knowledge that I've gained right now, I would like to ask, as a learner myself, what are some successful case studies of other countries, like our small country like Bhutan, that have advanced their semiconductor industry, and what are the lessons that Bhutan should learn from it?
Thank you for that question. I'll try and give you two, maybe three examples, if time permits. The first one I would like to talk about is Brazil, right? Brazil is a country not very unlike the countries in this region, right? And they at that time had a problem that needed to solve, which was balance of payments. The amount of dollars that they needed to import electronics was getting to a point where it was not sustainable. So we were very closely involved in that project. It was a 7-year project. We created 12 kind of training labs within 12 colleges in that country. And over a period of 4 years, over a period of 3 years, as the graduates kept coming out, we started incubating companies within those 12 institutes. And once those small companies started working on some parts of electronics and semiconductors, we actually brought some of our customers from outside who are semiconductor companies and said, can you now adopt one of these centers and technically mentor them? And the net result of all that was that at the end of the 7th year, these 12 were amalgamated into 5, and each of those 5 groups were picked up by one company or the other. And I'm very proud to say one of those groups was picked up by us. In fact, Cadence Brazil came out of that specific activity. The other companies like NXP, which used to be Philips earlier, HCL Technologies, all have centers in Brazil just because of that. The other example I would like to give is Bangladesh, which is right here. Bangladesh was driven primarily by their diaspora. And the reason I'm giving you this example is because it contrasts. One is a government-led initiative. The other is because there are so many Bangladeshis who went out and had illustrious careers in semiconductors, and they wanted to bring that technology back into their country. Today, after India, in this region, Bangladesh is the biggest market for cadence, right? And that has happened specifically because of the Bangladeshi Association in North America, a Bangladeshi Association of Silicon Valley, the Australian Association, and all of these people have contributed both money, time, as well as sending work into their motherland, and it has built that ecosystem there over the last 10 years. So there are multiple ways to do it, right? Of course, there's an organic way to do it like India did, but there's also other ways to do it which can accelerate it. I hope I answered the question.
Hello, my name is Tenzin Kalrubi, and I would like to ask you a question. So, how can AI affect semiconductor company? Like, will it decrease the number of intake of people, or will it increase? Because AI will need complex, IC circuits and chips. So what's the future of semiconductor company due to AI?
I think it's a question that almost all industries are asking, and of course we are no different. You have to look at artificial intelligence as something that makes your life easier, and that's true for any industry, right? So if you are an engineer and you have an opportunity to use the artificial intelligence algorithms that we have built, what it does is that it points you to a path that is a faster solution, right? Okay. Now, if you get from point A in the design to point B in the design at 1/3 the time, are we saying that the number of engineers required is 1/3 of the engineers required? Or are we saying that you can do 3 times the experiments than you were able to do earlier? And therefore, the reliability of the product that you're sending out is much higher. It's 3 times better than it was earlier. So it is a question of outlook, right? You have to look at artificial intelligence as something that makes your life easy. You have to look at artificial intelligence as a pointer. It points you in a direction of a faster resolution, and it will never ever replace a human brain, at least to the point of singularity, which one can argue is a few decades away.
I think this is an interesting topic, AI, especially for software companies. Today, a lot of the software companies have moved into the AI component, which helps accelerate a lot of the the actions required previously. The mundane stuff, correcting of errors, double checking, and all this kind of stuff. Does Cadence have an AI component that is going to be embedded in, to help accelerate some of the processes, or the mundane processes that was previously found, in this software region?
Absolutely, it is our next generation, right? Our products like Cerebrus, Verisium, all of these are AI products. What it does, it has two engines. It has got an inference engine, right? It's got a training engine and an inference engine. So the training engine basically understands how a design is done, and the next time it is done, it already has a lot of information about what are the things to look out for. So when the engineer is running a particular tool, the software is then able to take over and say, that is not the right path to go. Why don't you try this kind of thing, right? So across the board, in all our products, machine learning exists today, and in most of the products, the AI engines are also active.
So how about intellectual property? In the case where AI function is in the software itself, and I believe a lot of product designers, they want their technology to be proprietary, especially in this space of designing. And how do you go into navigating that security layer for that designer, for that product designer that says that, hey, I don't want this information to be shared, and keep it off the shelf, so that we want just our own company, our own beliefs that to be kept here.
So I think you need to make the distinction between a chat GPT kind of AI versus an application software kind of an AI. Our intelligence or training happens locally, specifically for that company, for that design group, for that specific design. Right? It is not learning things from external sources. It is learning things from how it was done in the past. Right, and that is critical for us. Right, it's critical for our customers too. Whereas a general, Chat GPT kind of a platform learns from everywhere. Right. Therefore, what is eventually included in the output of it, one cannot really state with confidence whether it infringed on any copyright or trademark laws. Which is why it is important that in an applications area like we are in, we keep all of that local, and that level of localization can be defined by the user. It can be local to a company, it can be local to a design group, it can be local to a design.
Thank you. Any further questions?
Ngaung from DHA. My question is, if the right kind of raw materials are available in Bhutan, and if you aspire to go for manufacturing the components like wafer in Bhutan, at this juncture, is it advisable? Will Bhutan be able to compete because of the global competition, and also, if so, how should we prepare so that like maybe in next 3-4 years we should be able to manufacture?
Thank you for asking the question. I don't have an answer for you. I'm not familiar with the material part of semiconductors. The same question was asked 2 times in the past 2 days that I've been here. And I have promised that I will find out and if you're from DHI, let Ujjwal know how to go about approaching that opportunity. As far as I know, the wafers that most of the fabrication units procure, that whole process, the supply chain is very tightly controlled. So I, from a design aspect of semiconductors, don't have visibility into that, but I have promised to go and find out and let some people know here. If you share your contacts with me, I'll send it to you too.
Well, generally, I think I can contribute a little bit on these areas. While in Singapore, we have a couple of these companies available. There's this company called Siltronic. They pull silicon tubes, all right? And apart from the raw materials, okay, which actually contribute to a very small portion of the procurement process. And even though I have done some analysis, Bhutan do have the right kind of minerals available for this sector, but the utilization for this is actually very small. The next area of concern is actually power. Okay, so the company in Singapore that actually pulls these silicon wafer tubes, okay, consumes so much power that it actually can light up a whole entire city in Singapore. Okay, that's the amount of energy that's required. So energy more than the raw materials required is the key over here. And for that, I think in generally the rule of thumb is that yes, the answer is we can have visibility that perhaps this could be an industry that we can explore over here. Any further questions? Okay, if there's no further questions, I think we will end today's symposium over here. Just to let everybody know, today Cadence is of very importance to us, especially in academics. So in CST, we are exploring how we can actually utilize Cadence expertise and knowledge on these areas to push, the boundaries of how a curriculum will look like, in our electrical, EEC, ICE programs, and perhaps, in the future we will have engineers, graduating from our institutions in Bhutan, even working in Cadence, and we would like to see a future like that happening. So for that, if anyone is interested in a topic like this, please come up to me and Jai Shankar, and then we can actually contribute more to you in these areas. Thank you very much.
Thank you very much. So a big round of applause for Justin and Jai Shankar. That was wonderful. Thank you, thank you, thank you. Sorry, can I make it now? Set up here. We've got about 5 minutes until the next session will begin. Join us in 5 minutes. Thank you.
Test, test.
You have audio in your presentation?
Audio? Yes, yeah, I have.
Audio. You want to test that sound? Audio is there? May I request the audience please to come forward here because they are going to run some demos with some thermal material and you will not be able to see if you are down there in the 27 row.
Okay. Thank you for joining us again, sticking with us. And if you snuck away during the break and you're in earshot, please come back in. We're going to continue our talks now with Sonoko Hayashi, talking about inclusive makeathon in Bhutan and future perspectives. Please give a big round of applause for Sonoko.
Thank you so much. Hello, everyone. Thank you so much for having me today. I very, very appreciate to deliver my talk in FAB23 in Bhutan today. I'm Sonoko Hayashi, come from Japan. My talk title is Inclusive Makeathon in Bhutan and Future Perspectives. The main subject of my talk is design for disability and co-design with community. So allow me to introduce myself again. I've been a director of FAB Labo Shinagawa since 2018 as an occupational therapist. I'm a representative director of ICT Rehabilitation Research Lab. We deliver workshops on how to use 3D printer for Japanese occupational therapists and physical therapists and people who are interested in our activity. And we deliver workshops on how to use 3D printers for Japanese occupational therapists, physical therapists, and the people who are interested in our activity. And always struggling how to disseminate and how our society accept this concept. We have published 2 printed books about 3D printing. The first book is a textbook on how to make assistive devices using 3D printer. And the second book is about the catalog book for assistive devices for 3D printing. We developed a special filament for 3D printed assistive tools last year, 2 years ago. The name of the filament is TRF plus H. I'm a 3rd year of PhD student at Keio University, measuring 3D printing technology and design. As an occupational therapist, I am actively engaged in promoting the use of 3D printing in Japan. Today, I would like to introduce our FAB Labo Shinagawa activities firstly, and secondly, later part of my talk is focusing on our Makeathon activities. I hope all of your comments and questions are always welcome. Thank you. So first of all, I mentioned to you earlier, I am an occupational therapist. So do you know what about occupational therapy? Or are there any occupational therapists in here? No one? Only me. So some of you know the name of the profession, occupational therapy or occupational therapist. But I guess most of you don't have detailed idea of what about it. So now I would like to start with a clarification of what is occupational therapy. Occupation in occupational therapy has a special definition. In occupational therapy, occupations refer to the everyday activities that people do as individuals, in families, and with communities to occupy time and bring meaning and purpose to life. Occupations include things people need to, want to, and are expected to do. Occupational therapists are specialists who use the occupation and provide interventions to increase client subjective occupational satisfaction. The word occupation is generally used in the sense of work or job, right? But however, the word occupation as used in occupational therapy is different. It has a human and philosophical meaning, referring to activities that are important and valuable to each individual. Firstly, occupational therapists define the client's occupation with the client. What activity do they want to do or be able to do? What situations and how can they be satisfied? Define firstly and try to improve their subjective occupational satisfactions step by step. Occupational therapists work in a variety of areas. Today, there are approximately 100,000 occupational therapists in Japan, and there are approximately 640,000 occupational therapists worldwide, maybe 2 to 3 persons in Bhutan. Yeah. We identify occupations that need to be improved and provide interventions for the performance of daily living skills and improving the environment. Our interventions include the selection and fabrication of assistive device. Customized handcrafted assistive devices made by occupational therapists are so valuable for the users because The reason is very simple. With the device, the users can engage their meaningful occupation. But without the device, the users can't engage their meaningful occupation. That's why. So now we are fabricating assistive devices using 3D printers. We can make assistive devices that look better in design and simple and stable. If we could utilize 3D printing technology, we can share the 3D printing files for assistive devices. Now, occupational therapists don't need to fabricate these customized assistive devices from scratch. In Japan, the number of occupational therapists who are using a 3D printer is increasing. Sometimes a Japanese research journal of occupational therapy are full of the topic of utilization of 3D printing technology. I believe that I'm a leading person in that field in Japan. So this diagram expresses the relationship between design and occupational therapy. If the design would be an action with the action to make a system of something with replication and imitation. The action of the care is placed on the opposite side. Because every humankind has a different personal trait, with different backgrounds, different physical status, different ways of thinking. So it's so difficult to duplicate. Actually, the attitude that never duplicate is the reality of the care. I believe that the concept of occupational therapy or occupational therapeutic way of thinking and the utilization of 3D printing technology can make a good relationship between design and care. All the activities that I organized are based on this concept. So please listen to an introduction of our activities. I will introduce to you these 4 activities. Firstly, I would like to introduce to you our open platform assistive tools. So as I mentioned earlier, producing customized handcrafted assistive tools for clients has been an important intervention for Japanese occupational therapists. Now we are producing assistive tools using 3D printers because sharing and storing printing files can solve many challenges for handcrafted assistive tools. So my colleague and I fabricated a lot of assistive devices using 3D printer. And this is an image for our exhibition at Maker Fair Tokyo. Over the past few years, we have held numerous workshops, events, and exhibitions. In the exhibition, we try to make it look fun by using various colors like this picture. We'd like to share not only digital files, but also the concept of occupational therapy to all the makers across the world. Most of the case, we are using this FDM type 3D printer because they are inexpensive, easy to buy, and easy to handle compared to the other types of 3D printers. Here is the homepage of FAB Lab Shinagawa. Click on the tab named Assistive Devices. You can see various assistive tools. For example, this is a PET bottle opener. A remarkable aspect of this platform is that all the models have completed an assessment by occupational therapist specialists. We developed this platform almost 4 years ago. And I have published one peer-reviewed paper on this assessment and development. This is a slide for how the platform was built. Initially, I asked many occupational therapists and the others to join this project. And several times, I delivered online lecture to participants on how to make assistive devices with 3D printers and how to share the files. Once we collect the files and information on the Thingiverse group named FAB23 Japan in 2019. Then we 3D printed all the files and conducted an assessment with some occupational therapists. Only the files that have passed the assessment were published on the FabLab Shinagawa platform. Last year, we added this web service to our platform. This is size adjustment service. We call this parametric service. You can create customized 3D model files for assistive tools using this service. Just put into the exact size and export the file. We can use Google Translate on this website. This is our parametric service. We have 21 templates on this service. There is a range of equipment from assistive tools to small slopes and rehabilitation equipment. I will share you the brief introduction of the parametric service. This is a pen holder. This is a kind of slope. We can change the length, height, and the side slope. And this is a holder for a pen. We can change the diameter, height, and sectional profiles. And I would like to introduce some applications of how 3D printers are now being used in Japanese care settings, including assistive devices within the FabLab Shinagawa platform. These are equipment for rehabilitation, not only exercise cones, but also the base of the cones we can arrange. The design of the tool can lead the movement of patients in the direction the therapist wants to encourage. We also can create the tools for activities of daily living. The left image is the reacher. It helps the reach, for example, by people with rheumatoid arthritis who have a limited range of motion in their joints. And the right side image is the tools for dropping medicine in the eyes. This also helps with joint range of motion and muscle strength. And these are the extension tools for the ordinary assistive devices. The left image is an extension of the armrest of the wheelchair. The right image is an extension of the handrail of the walker. This is also extension tools for assistive devices, extension of the arm support lock pin of a wheelchair. Let me show you a video. You can see the difference between before and after the extension parts in this video. This is before putting on the extension parts. And this is after put on the extension parts onto the pin. If this old woman can lower herself this pin, she can transfer from her wheelchair to her bed, or she can transfer from her wheelchair to the toilet seat by herself without help. This is very meaningful for her and keep her dignity. This left image is an extension of the wheelchair for hemiplegia client. The right image is a creation of a joystick for an electric wheelchair. Both of the 3D printed extension tools significantly extend the user's range of self-mobility and activity. 3D printing technology is good at connecting tools firmly and beautifully. These are the examples of the creating connectors to position touch sensors and physical switches where they are most needed. Even people with severe motor impairments and only a fraction of their body able to move can communicate, play, and control their environment with this tool. If the appearance of such tools is satisfactory for users, they can go out with them. It will definitely lead to an expansion of social activities for people with disabilities. 3D printers enables us to make a product can be tailored to the client's ability in 1 millimeter steps. This is a switch base. It enables users to enjoy gaming, even with a few motor movements. Place many micro switches in here correctly. Here, micro switches. This switch and tools allow this severely disabled person to enjoy playing games on Nintendo Switch. This is an actual video playing a game on a Nintendo Switch. A lot of people with disabilities often hold back from their ability to enjoy themselves. But how can we live without having fun? It is more important to enjoy life than to be independent in the activities of daily living. Make having fun a top priority. Perhaps all of you in this audience may be experts in enjoying life. So many case studies have been gathered and that we have published them in our catalog book. So if someone who have our catalog book, please hand to the audience one by one. Thank you. "3D model files of more than 200 assistive devices can also be downloaded from this catalog book by scanning the QR code. We share G code as well as STL files, so you don't have to use any particular software. In Japan, the beginner's training course begins with the download the file and 3D print direct from this website or this paper book. And we are going to develop a new platform named Kokuri Hub. The name comes from co-creation and FAB. We will develop a more convenient, useful, and sustainable platform on the internet. We will attach the community map. It enables users to reach the nearest collaborator easily. Also, we will attach the useful brief reference document on the platform. We call the document cheat sheet for production of assistive tools using 3D printer. I will share the cheat sheet with you. This will be very useful, not only for those who want to make assistive devices, but also for those in the field where 3D printing is used in education. The first sheet is here, the process of producing products by 3D printing. And the second is here, recommended applications and 3D printing settings for the major materials. The third sheet is here. This is about some effective way of improving safety and durability. The next sheet is about some effective way of creating better occupations in the process. And the next sheet summarizes the overview of 3D printing troubleshooting, overview of maintenance of 3D printers, and the next sheet provides a cheated overview of 3D printing and troubleshooting. This seems very convenient, right? So if you are interested in this cheat sheet, you can download it from here So please scan this QR code and try to download. We seriously want to democratize production with 3D printers. So now I would like to move on to the next introduction of our activity. We have developed a material that is ideal for assistive device production. We are promoting this kind of joint support tool. We occupational therapists call this Sprint. FAB Shinagawa and Japanese material company Unitica Ltd. collaboratively developed this special 3D printing filament TRF plus H. We call this method PVC. For example, 3D print in flat shape like this. This method can reduce the printing hours and can make the surface of the product smooth. We can process it with a hairdryer. After printing out, we can easily twist and stretch the products. Heating with hairdryer like this. And user can stretch and easy to twist like this. I think occupational therapists like to tweak the product even after it is printed out. So this filament is very convenient for caregiving settings. And this filament has special additional properties. We succeeded in reducing the rate of production of crack on the products. And the most remarkable application for TRF plus H is single materials and multiple functions. Here is a video of processing at room temperature. Everything is initially stiff. Apply warm air with a hairdryer to the mesh-like part at the top of about 10 seconds. As you can see, it can be transformed at once into a spongy and elastic state. The filament won a finalist award at the Material Driven Innovation Awards 2022 as a material for well-being. TRF plus H can reduce 3D printing hours and support material with a view to post-processing. While making the use of digital, people can add the final value on the products by their hands. We highly recommend using the filament in caregiving settings. If you have interest in domestic and also international orders are accepted through this link, so please check it out. If there is time at the end of this talk, I would like to give a demonstration and a short workshop experience with you here. And now I would like to move on to the next introduction of our activity. It's a collaborative project with a big Japanese company, Muji. Muji is a global store with natural and simple design. A 3D printing service will be has been launched with FAB Shinagawa at the largest Muji shop in Tokyo, which opened almost 10 months ago. Extension parts that make Muji products easier to use for a wider variety of people, including the people with disabilities, are 3D printed and sold in the store. And products are 3D printed with recycled filaments from Muji products. We will do our best to expand this project throughout Japan, and ideally, we would like to expand it globally. Now, I would like to move on to the introduction of the last activity, that is a makeathon with needle knowers. Makeathon is a workshop with time constraints that brings engineers, designers, therapists, and makes together to answer assigned topics through creative solutions and working prototypes. Our Makeathon always involves the person with disabilities, and we call them need knower. Many people have participated with different backgrounds, from the family and friends of the disabled person to occupational therapists, caregivers, makers, and the others. The event usually lasts from 1 to 3 days. The person with disabilities will attend the event from the first day to the final moment. Our Makeathons generally proceed in this way. Need knowers, introductions and interviews and observations will each them will be conducted over time in a round table, team building, and conducted from here. They split into teams to carry out ideation and prototyping or iterations. And then conduct testing, defining the testing again and again, as long as there is a time, and do a presentation in front of all the participants. This is the documentation about our co-creation process and the outcome of our Makeathon. The goal of our events is to make all the results available on the internet. Very long documentation. So I would like to introduce the latest of our Makeathon named FAB23 Tokyo 2023. It was Japan and France joint 3 days Makeathon held in last May. Almost 35 people participated from Japan side and almost 15 people participated from French side. The venue was Miraikan, the National Museum of Emerging Science and Innovation in Tokyo. Let me show you the summary video. We call and simultaneous interpretation was used as the opening and the final presentation event. Three needle thrust and 3 projects.
コクリエーションのことを考えると、大体よく知った隣人が何らかの、違いを抱えているので、それとうまくコミュニケーションをしたいか、何か手伝ってあげたいか、あとはそういった世界があることを知ったか、そのあたりだと思うんですね。で、そうやって考えると、一番重要なのは、隣人になることであって、それのきっかけを今日知れて帰れるのは素晴らしいことだと思います。
これまでは、飽きたら捨てるとか、終わったら捨てるだったかもしれませんけど、それをもっとこうね、作り変えていける。そういうところの可能性が高まっていくんじゃないかなというふうに思います。ですので、この3日間だけでやっぱり終わらないっていうのがすごい大事ですよね。
今回の体験で動いた気持ちを周りの方々とシェアしていただいて、観戦させてくださるとすごくありがたいなと思ってます。So thanks to many collaborators, the event was a success. So sorry for a long preliminary talk. Now I would like to conclude the introduction of our activities and now come to the main topic of the title of this talk. This is a talk about the inclusive makeathon in Bhutan, which was challenged this year with CST students targeting people with disabilities living in their local communities. The venue was FAB23. And first of all, I would like to introduce a makeathon that took place in March this year. At the time, 2 FAB workshops were offered before the makeathon conducted. The makeathon took place over 4 days from 6 to 9 March, each lasting 3 to 4 hours. One FAB workshop was conducted on 3D scanning, and the second workshop provided information on 3D printing of different special materials, including the TRF plus H and the other materials. Local disabled people came from local special education school. So same as usual, the event was conducted with need-to-knowers participation from start to finish. At this time, we conducted with 2 need-to-knowers and 2 teams. And for the interviews, we used the format we use for our inclusive makeathons. Each member of the team listened as they filled out the interview sheet and used it as a guide to organize the team's ideas. And based on these interviews, the team sketched ideas, shared them with the item, and decided on the tools and the devices to be fabricated. The next day, they immediately began prototyping. We then proceeded with testing, prototyping, and documentation in parallel. On the final day, each team gave a presentation and shared their results. Let me introduce one of the team's documentation here. On the FabLab CST website, we can see this documentation. It includes the idea sketches of every team member. It describes why they made this device for the need-to-knower. I'd like to show you the summary video. This inclusive makeathon has been conducted from 6 to 9 March this year. In Bhutan, disabled students and the other students have different facilities for study, so they don't communicate a lot normally. I hope this initiative would be a big start point for them to communicate and collaborate with each other for their better future society. So now I would like to introduce this interview format, which we are using on our Makersome named Occupational Design Worksheet. The left part of this worksheet has a function that helps the user to conduct the interview without missing the important point of the interview. And the right part of this worksheet has a function that allows users to draw their ideas based on their interview. I will show you an example. This documentation comes from a publication challenge which has been conducted in FAB Bhutan Challenge, FAB23. FAB technology enables us to fabricate more personalized devices for the need knowers. So we prioritize the specialty of the need knower. Specialty is indicate the, this is the specialty section. This is specialty indicate the user's background and interest, strengths, or the role of the society, such as the specialty we have to include our publication. And in this characteristic section here, characteristic will make clarification of their disability. After finding out the targeted activity, we also try to hear when, where, with whom the activity will be conducted. Actually, these interviews are so occupational therapeutic. Now I'm working on my doctoral thesis, and the part of my thesis title is Occupational Design. Occupational design is a kind of methodology of design. This is an idea from an era when 3D printed were democratized to occupational therapists and citizens. The first part of my talk, I shared with you this diagram. I believe that the concept of occupational therapy or occupational therapeutic way of thinking and the utilization of 3D printing technology can make a good relationship between design and care. For developing this methodology, interview studies were conducted to identify the occupational design concepts. I interviewed special occupational therapists who are developing the assistive devices and provide to their clients, and they conducted research or lecturers making great contributions at clinical settings. The interviews were conceptualized using the KJ method. Sorry that the details are described in Japanese. I found figure out the 6 components and their flow. This is a diagram reconstructing an overview. I call this double triangle for occupational design. The left side triangle, we will make a circle for the start point. We have to change the mindset with fabrication in any way. And the right side triangle, we will make a circle for continuity by involving the right key persons and create re-accessibility users. Daily habits and social roles can be positively changed here. By running this circle, utilizing the concept of 3D printing and FAB, design can become care. In terms of occupational design worksheet, it also includes the point of occupational design. Consideration for key persons to be involved here, creation the ease of accessibility is here. One of our cheat sheet is sharing this methodology with practical images like this. Now I will share with you how I have fabricated 3D printed assistive devices for Need No War in the FAB challenge, which was held almost a week ago in CST Punturin. The project name is Another Soul. We've challenged to fabricate something good for the improvement of daily life for a student. He has a right side hemiplegia. He can walk without help. He can put off his shoes by himself. But due to the deformation of his ankle, he couldn't walk for a long time. When he walked, his ankle directly touched to the floor. So I decided to 3D print another sole between his ankle and the floor, like the right side image. Occupational design worksheet for this project is here. Specialty for him is that he likes the shoes which is currently using. He is very like the shoes currently using, and he can put on and put off his shoes by himself. So I decided to keep his favorite shoes in as much condition as possible. It means I don't want to change the style and how to put on, put off the shoes, even in the shoes of the color. After measuring the length of his leg, a 50 millimeter difference had been observed. The right side paralyzed leg was shorter than the other side. So I decided to fabricate 25 millimeter height another sole to 25 millimeter height, this point. To reduce the big impact from the floor, I adjusted the infill percentage 70 to 20%. It gradually changed 70% to 20%. And the infill line width 0.8 millimeter to 0.4 millimeter with 0.4 millimeter diameter nozzle. The Need No War accepted this product and he satisfied the results. We proceed in fabricating another sole, succeed in fabricating another sole. I can say most of the case, we should avoid making a big difference when it comes to fabricate assistive devices with FAB technology. Because making a big difference may have a risk of exploiting the current ability of the users, and it may undermine the dignity of the users. Makers has a lot of seeds to be applicable, but we have to take care of the impacts of the products for the users. Using FAB technology, we can make small things for users and can change the shape or function step by step. Ultimately, the action make a big impact on users and their society. So now I would like to proceed the discussions. How can the project to create 3D printed assistive devices in Bhutan be expanded? When we consider all the actors for this initiative, I would like to share this double triangle diagram again. Users, therapists, teachers, engineers, makers, students have to make a first circle to make the change the mindset. And the right side triangle, involvement of family or friends, teachers or caregivers is necessary to it. And it includes the accessibility and how to procure the machine and the materials and how to make the citizens accessibility to it. It includes the accessibility to the files for fabrication are also important point, this point. We already know the impact of the FAB technology, but most of the people don't know the impact. So we have to provide the course of experience to all the stakeholders that I mentioned before. And this year, some CSD students and the teachers and some students already experienced this copy and test and use the 3D printed assistive devices. For the next step, they need to conduct the test and adjust process, the iteration process with the real users and key persons. The more the number of people who understand the impact on this initiative increase, the more the number of people who could change their life make this second circle. I would like to conclude my talk with this slide. We shall work together to find and design the occupation with users. And please try to find what activities are most meaningful and important for the person. What makes the person excited? What makes the person take action? What state of being is more satisfying for the person? And please find something small but meaningful. First of all, please find your meaningful occupation and try to share them with the people around you. Thank you so much for your attention. That's all about my talk today. And all your comments and questions are welcome. And if we have a chance to demonstrate or express the filament TRF plus H production, please gather the front and try together. Thank you.
Thank you. Thank you very much. Any questions before we move on to the demonstration? Hang on one second.
Hi. One problem with co-creation is that it cannot really be done to scale, and it has to be customized for each user, right? So there's a lot of time that you spend for kind of value adding only to one customer. So how does the business or the economics work for that? While I do appreciate the human value of it, but for that to continue to sustain, there is also an economic value that has to be there. So I'm wondering how you achieve that with your lab.
Good question. Thank you. Thank you for your question. So far, our business model constructed with 2 points. One point is come from, I mentioned to you earlier, collaborate with the company producing the daily life products like Muji. And the second point is we are accepting the new accepting the we are accepting the production of the usage for the new special materials filament for the materials company. So so far we are considering to make most of our model make open source because the market for the assistive tools or assistive devices are limited. One assistive devices, not so many users exist, but if we could see across the world, we can contribute a lot. So we insist we will make our 3D print file to be a open source file at the moment. Yeah.
Thank you.
Thank you.
We may have time for one more question, but I want to make sure that we have time for the demonstration as well. Do we have any other questions before moving on to the demonstration?
Thank you very much for sharing. It is incredible work. We've started doing something similar in Singapore in the public library. But to the gentleman's question, we still haven't quite figured out how to make it sustainable. It has to be personalized, it has to be customized, and it has to come from a place where the need knower, as you say, is able to afford it. And so if we're able to use digital fabrication to reduce the cost to the individual compared to anything else that's in the market, then the individual need knower, the user, should be able to pay for it as well. We haven't quite figured out a model yet, but right now we are experimenting with a pay-as-you-like model, and that seems to be working enough for us to continue this work. But it is a difficult situation, but has a phenomenal impact. So if people have ideas as to how to tackle this, it would be super useful.
Thank you so
Thank you.
much.
Just a comment to my question, your answer, and his comment also together. So what I believe is already when we are working with differently abled people, that's an extreme user group, and we have a minority of a market. We cannot really expect a lot of economic value there. And if you are co-creating and particularly addressing the lower economy group, that's even tougher. So I believe personally that unless the social systems, the socio-political system also comes into picture to help and support, it won't go forward. So I thought this is a good forum for me to learn how different countries are doing. Thank you for your input from Japan and Singapore too. Thank you.
Thank you.
Thank you. So would we like everybody to come up or a small group of people to come up? What's the best way?
Small group.
A small group of volunteers like to come up to the front? Gather around here and anybody who'd like to come up. So, a little bit bigger group than that.
I will do demonstration firstly, and please follow my demonstration.
Perfect. Do you need them? Okay. Yeah, okay, okay.
This is produced by TRF plus H filament, 0.4 millimeter nozzle size with the infill pattern gyroid adapted and 28% infill percentage. I found this percentage and infill pattern is the best for this application. Soon be turned to be elastic like this. I always recommend to make first step to make this shape ribbon. Bow tie, yes. Why? It's very fashionable, right? And yeah, in the room temperature, it will be solid like this. Yeah. And we can change the shape again and again with heating. Yeah.
This material you said it's not available in Bhutan, right? So are you planning to do anything about making it available here as well?
Yeah, yeah. So that's why I provided the demonstration here. Please have the ribbon again. Oh, thank you. So Okay. Yeah. Do you want to try? Yeah, we prepare some of the samples here. And after try, you can keep this sample. Sorry, pardon me?
This, can you increase the thickness or does it?
Can change the thickness. Yes, yeah,
So then you have to put more heat, right?
yeah, yeah.
We're going to begin transitioning to the next presentation, but please give another big, huge round of applause to Sunoka. This was absolutely wonderful. Thank you so much.
All the panelists are supposed to be seated in the on the podium.
Panelists making their way to the stage. Wait, don't sit on the microphone.
Oh, okay.
Thank you once again for joining us, for sticking with us. We're going to continue on with our, I believe this is our final panel of the afternoon. This is 1 year of Fab Lab CST Funschling as a community lab, moderated, presented by Koji Yamada. So let's welcome them all with a big round of applause. Thank you very much.
Kusan out. My name is Atsushi Yamanaka. I'm the senior advisor on digital transformation at JICA Tokyo, and I'm going to be the moderator for these sessions. Hope that you have actually patiently waited for the best presentations for the day. The best actually comes last, isn't it? So I have a very exciting panelist here. The title of this session is called 1 Year of Fab Lab CST. Funtoring as a community lab. And I'm sure that many of you actually went to Funtoring during the Fab Challenge last week. So you're familiar with some of the facilities that CST actually are offering. But we'd like to actually hear from them. These are the people who are the movers and pushers of the Fab Lab CST. So we'd like to hear from them some of the challenges and opportunities they have encountered during the last 1 year of making CST a reality. So we actually have a panelist here, Dr. Cheki Dorj, the president of the College of Science and Technology. So can you give us an applause, Dr. Cheki? And Ms. Karma Keduz Udon, she's the Fab managers of the Fab CST. And we have Mr. Tenzin Dorj, he's a technical lead at the Fab Lab CST. And then we have Mr. Karma Wangta Funto. He's actually an alumni of the CST who has actually benefited greatly from CST Fab Lab. And then last but not least, Mr. Nanda Kumar Gurung. Yes, he's actually a co-founder of the Fab Lab, the first Fab Lab in Bhutan. So he's sort of a living legend in terms of Fab Lab history in Bhutan. So let's actually start. Also, we would actually start with Dr. Cheki. Dr. Cheki, can you actually, not only the welcome remark, but can you actually give us the overview of the CST Fab Lab?
Good afternoon, and thank you, Atsushi, for giving us this particular wonderful platform as a moderator. And good afternoon, everyone here who are there as an audience. The history of CST Fab Lab CST goes way back where the funding support was made by JICA, and the establishment of the Fab Lab had a challenge where the COVID set in once the funding was committed, and we had lots of struggle to complete the Fab Lab in totality as well as the delivery of the equipments. However, after 1 year of getting we are hardly a year, August would be 1 year of our journey as Fab Lab CST. But nevertheless, we had a really wonderful experiences after the establishment of the Fab Lab CST. To us, this was an eye-opening and opportunity to collaborate with local. We obviously expect our staff and students to use the Fab Lab as well as their assignments being conducted in the Fab Lab. But when it comes to community, we managed to create a vibrant community, be it schools, school teachers, and the community around our Fab Lab. So these were some of the happenings that took place after the establishment of the CST Fab Lab. On the participation side, we saw there are lots of eagerness and the participation that is taking place, be it from the student and be it from the faculty, be it from the school-going children. There are times where the chief advisor, who currently is the Koji Yamada, who along with lab manager and the technical team has difficult times at times to really get the schedule conformed. So these are some of the things that has happened after the introduction of the Fab Lab CST. Now, again, when it comes to FAB 2023, we were fortunate and had an opportunity to receive 14 participants, international participants, and there were four Japanese, again, coming all the way from Japan to participate in the FAB Challenge at CST. This was, again, an eye-opening And this was a wonderful event where we managed to host them at CST as a FAB, one of the FAB community FAB lab. And there were wonderful events and sharings and network building along with this particular challenge. So these are some of the openings that has been made with the institution of FAB Lab. And we would like to thank JICA for assisting us with the fund and establishing the FAB Lab. I will leave here and I would let my other colleagues to speak in terms of the collaboration, how it is taking place, day-to-day activities, and then other things that we have as a challenge, we will be leaving and parking it for other Q&A and other related activities. We will be parking it for other sessions. Thank you.
Okay. Thank you, Dr. Cheki, for the nice welcome remark and then the overview of CST. Now, and then can you hold on to the Q&A? As Dr. Cheki said, we're going to be waiting for the Q&A at the end. So we will be welcoming, and please actually formulate your questions so that we can grill them for different questions. So now I'm passing the mic to Ms. Karma. Ms. Karma is a FAB Lab manager, and she can give us the overviews of the day-to-day management of the FAB Lab, as well as some of the challenges that she have encountered in the past 1 year of FAB Lab CST. So, Ms. Karma, please.
Thank you, Mr. Hamanaka. Good evening, ladies and gentlemen. Thank you very much for this opportunity to share our experience of installing FAB Lab CST and the positive achievements and the challenges that we face and are still facing. But thanks to FAB23, we have had an amazing experience and we are really positive looking towards the future of FAB Lab CST. But before going on to that, I'd like to share that in the FAB Lab CST, of course, we had to do a lot of orientation and awareness, and it still seems that we have a lot of work to do to orient people and let them know the potential of fabrication lab within the community. To begin with, we have a small team within the College of Science and Technology who looks into the operation of the Fab Lab. But we found that the student community was really active and they really wanted to make use of the Fab Lab once they knew what could be done. We as beginners were also very new to the machines. We saw these 3D printers as a miracle machines in YouTube. I'm sorry to say that, but we didn't have a machine back then. But now we can say that, yes, we know 3D machines. They are our friends. So with that, our students were also able to see those machines, see their capabilities, and make use of these machines after coming to the Fab Lab. So apart from the staff team that we have within the Fab Lab CST, we also have a small student management team. We believe that students, when given the opportunity, can always lead and do impossible things and make it possible. So with this, challenges, of course, like President Dr. Cheki mentioned, that we need to do a lot of reaching out. We are very new still, just 11 and a half months old. We are not even 12 months. So we see a lot of opportunities. Looking at our students and the growing enthusiasm, we see that we can do much more than what we have done over the 11 months that have passed. We are also having a bit of a challenge reaching out to certain parts of the communities because of a lot of activities happening within those institutions. But still, we are trying to look into the future and bring a kind of a mini brand to our Fab Lab CST so that we specialize in that particular area and take it forward and also help our community while doing that. So if I may share, the challenge also focused on the assistive technology, and also we are trying to address the waste management by using parts of aluminum which was recycled from aluminum cans. So with this, I think I'd like to stop here. I can go on, but I'd rather stop here. As you can see, I can talk a lot. So thank you, Mr. Hamanaka.
Thank you very much, Ms. Karama. I'm sure that we're going to ask you a lot of questions afterwards. So may I actually pass it to you now to the Mr. Tenzin Dorj. He's a technical lead, so he's a technician who is actually looking after, when the student actually utilize the machines, I'm sure that they break them. So Tenzin Dorj, I think he's actually the one who actually make miracles of fixing these machines to make sure that they are operational, right? So can you tell us a little bit about, from your perspective, from a technical lead, how is the CST journey for the last 1 year has been?
Thank you very much. as already have mentioned by Sir, I am the technical in charge of the Fab Lab CSG. Actually I'm not just a technical focal person for a Fab Lab, but I'm also looking after the other lab which I was there for to take the lab as a I'm 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 really sorry. Uh, Usually, my contribution for a Fab Lab is being the focal person. Now, where I have to invest a whole lot of my time uh, during the setting up of the Fab Lab. I have to really input my time, and my contribution for a Fab Lab is that. Uh, I'm sorry, I have to repeat. I helped setting up the lab machines and all during the setting up the Fab Lab. We also took many ideathons which help our friends to learn more about Fab Lab and other things. We did taking the students orientation and guiding the students usage of Fab Lab during their final year project. I think they really did amazing things after the Fab Lab came into our CSG. And I think there are amazing projects that will come after from now on. I'm looking forward. This Fab Lab will be a very good place for a student to enhance their knowledge and bring their knowledge to the next level. Thank you.
Thank you, Tenzin Dorj. I'm sure that you have more to say about some of the challenges that you're facing every day. So let's actually wait for that. Now, can I pass it to the mic to actually the students who actually have benefited from CST Fab Lab? Yes. May I actually introduce Wangta? And then he's actually an alumni of the CST, and he can tell us all about like how he benefited from CST Fab Lab.
Thank you, Yamanaka sir. I'm Karma Rapunzo, and I am a recent graduate of College of Science and Technology. In a few days, I have been here. I have attended almost all the talks, but I feel like I'm the least qualified here, and I'd like to thank for the opportunity. Regarding my experience as a student user of the Fab Lab, I remember the first training that I attended. That was in 2021. So I believe I was still in my second. I just completed second year, and then there was the first session that was hosted by the chief advisor, Mr. Koji Yamada, and then he was giving a training on 3D printers. So I attended that training. I got the opportunity to attend it, and then after I created that my first design and printed that using the 3D printer, it changed my perception of how I saw the world. So over the years, I have whenever there were sessions, I tried my best to get the opportunity, and then there were many sessions like many different kinds of 3D printing, designing softwares, and then also like microbit workshop or IoT workshops. I have always tried my best to attend them. And then once the inauguration, Fab Lab CST was inaugurated, it actually made me very happy because because there were so many machines, and then I already had some kind of experience, so it was very happy. I thought I could use some for my personal projects as well. And after that, I also did one project which was related to the 3D printers. So I did one project called turning PET bottle waste. I was recycling it and then turning it into 3D printer filament. So I know that for most of you, maybe that concept is not very new and it's very old, outdated concept or something. But I believe that in the Bhutan's context, that is the concept of 3D printers itself. It's very recent. So I thought maybe like that kind of recycling plastic bottles was even more more fascinating. So that's why I did project on that one as well. And then we as a group, we mostly designed most of the components ourselves. We used the 3D printers in the FabLab CST. And I also did other smaller projects, like we also recently in the spring semester of 2023, we had a fashion show conducted. And then there also, I got the training of using the embroidery machine and the sewing machine, and then I used them to make some costume for our own class. And then I also tried to teach it to other to my colleagues as well, and then let them make their costumes as well. So in that way, I've used some of the equipments down there, and by learning how to use that kind of equipments, I felt like it inspired. It actually developed interest in some of my peers. Before some didn't even bother attending the trainings, but then after I completed my training and I saw and I shared my experience of how I used or what kind of creations that I could make. So they actually saw that they could transform their idea into reality. So I believe that was very important. That was a very important contribution of opening FabLab CST down there. Thank you so much.
Thank you. Thank you, Wanda. From the student perspective, I think it's very, very important to actually have this kind of facilities, because I'm really intrigued when you said from idea to reality. Yes. And I think like eye-opening. I think these are some of the keywords which is very, very important for many of the actually CST students and also the youth in Bhutan. So from Nanda, so you've seen this development, yes? So you're the co-founder of the first Bhutan Fab Lab. Maybe let's actually approach for that. Without this past Fab Lab, you wouldn't see this actually, right? The Super Fab Lab and also other Fab Labs as well, which exist in Bhutan. So from your perspective, how do you see this evolution of Fab Lab communities in Bhutan? And how do you think this CST Fab Lab is going to be, we hope that it's going to be a leading sort of, Fab Lab in Bhutan. How do you see the role of Fab Lab CST? So can you tell us historical, perspective as well? Because we all want to know how it started as well.
Thank you so much. Firstly, I would like to congratulate the CST Fab Lab team for successfully establishing the CST. Since beginning of their establishment, the Fab Lab Bhutan team have been totally involved in our contributions in the successful establishment of Fab Lab CST. So it was a great privilege for us to share our experiences and then our knowledge and skills to them. And then it was just as a Fab Lab as a Fab CST ex-alumni of the CST and then former Fab Lab former member of the Fab Lab Bhutan. So I would like to share my experiences and the contribution that I made to the Fab Lab CST. So firstly, beginning of the CST Fab Lab, so the Koji Yamada sir was very totally supportive to us, and then we went to the CST for delivering the trainings, and then even we took all our machines example like 3D printing, 3D printer, CNC milling machines, and those the electronic gadgets that we can help them to understand what the definitions of Fab Lab actually it is. So that was our, and then meantime, we have been giving our trainings to them, and then recently I have been also carrying out many trainings program like a microbit training, even like a PyTop training. So many trainings I have done to the CST Fab Lab, and then enhancing their knowledge on the Fab Lab. So that was my biggest contributions to them. And then so looking at the perspective of the Fab Lab here in Bhutan, it's quite fascinating as well as uh, uh, like not to get too overwhelmed or to get not to get too excited with the Fab Lab here happening, because sometimes with the face of that excitement we tend to lose our our way back a journey how we have started actually. So that's very important. So and then as a Fab Lab CST, they have been very supportive to our former Fab Lab Bhutan team member in any contribution, like even in the building capacity building, and then we also shared our skills to them in many areas. So when we see the Fab Lab, it's like something that we can develop where the student can develop a multidisciplinary skills, and after having these multidisciplinary skills, the students can then focus on their core skills when they reach to the job market. That's very important. That's what I see in the Fab Lab. And as a former student of the Fab Lab, CST College, I was very excited to see the relevancy of the Fab Lab to our engineering skills, to the knowledge that we gain during the course of during the course of my time in the college. And then when we reached to the when I was using the tools and technology to the Fab Lab, it was very relevant. And then it is also depends on the individual perspective how we take that things and how we learn further. So that was very important. And then of course looking through my experience as a former Fab Lab Bhutan member, the sustainability was one of the challenge. So sustaining of the Fab Lab, how we run the Fab Lab, and of course we spent more than 2 years and giving an advocacy, which means reaching out to the various level of people, like starting from the ministries to the local community, like what the Fab Lab and how it is going to bring impact to the community. So that was but we focused like almost more than 2 years doing that. And after that, we took the Fab 2.0, that is a making machine projects, that where we can, from the existing machine, where we can build and then enhance the local people expertise on developing of that machines. So, and then we focused on developing that machines for the STEM educations. That was our like biggest achievement, and we have been like till then we were successfully like able to build those machines like a 3D printer, CNC milling machines, and laser cutter machines. That was our biggest achievement. I think yesterday also Koji Yamada showed here in the stage, like that was our biggest achievement so far actually. And then coming back to the sustainability, there are like as such as per my experience, the Fab Lab can look into the different perspective of business model. I mean, one can be an educational model where they can give trainings, and then one can be another one can be some kind of like enabling the business model, which means providing service to the local community. And then another one is providing platforms like incubation platforms to the entrepreneurs. That is another business model. So we during our time, there was no one. We even got chance to like do the Fab Academy, and it was like everything like learning ABCD, something like that. It was from scratch. We have been learning, and we have been learning through all those like iteration, learning, unlearning, and relearning. That's our like process that we came and we achieved that one. So like maybe like this much only. Maybe if you have questions, I'm ready to like happy to answer them.
Thank you, Nanda. Thank you. So, Dr. Cheki, obviously you're doing something right. Yes. You see all these proactive, very active actually students who actually became really the core sort of supporters of Fabless CST. How are you actually creating these future, future basically next generations of like future talents in CST? I would like to actually learn your secret behind it. That's number one. And number two, what was the reason? Why did CST was chosen to host the Fab Lab? It's quite a new actually institution. I mean, quite a new actually facility. So I would like to actually ask you these two questions. But number one is going to be more interesting.
Thank you. Let me go to the second question first. So to
Yes,
just
please.
to answer and address the history behind. Once upon a time, when the students were passionate in creating and innovating things at the college level, there was a stage where the students had to do many things repeatedly with their own hands, be it with the carpentry tool on trial and error basis, or be it with the cardboard boxes, and they had been struggling a lot. And then things stuck in me. There was one stage where I'm fascinated in creating paper recycling machine. So I had given a challenge to a group of students. There were 3 groups of students. 2 failed miserably, and then 1 stood and took up the challenge. Then a turn came where the students went with the idea back home during winter vacation and came with the rudimentary, crude product which could really create paper recycling machine. And then it struck my wonder, if given the choice, students are there to create, was the big thinking that punched on my head. Then I was saying, okay, how can we create things that enable students to take that type of work? As I was Googling, then the Fab Lab came in and popped in. Fortunately, then Koji Yamada was the chief advisor here. So he came there and we discussed at length how could this type of opportunity be garnered. So through such dialogue, I shared the same idea to him, and I know he remembers vividly at this point of time even. And then came a stage where we could put up a proposal to JICA for technical assistance funding. And then that's how we secured the funding, and now it got realized. So this is a story in short, briefly. And then when it comes to now, having got established Fab Lab, and then little more than 11 months now, I see much more opportunity to create many things. I've seen students, some spending their nights till 12 a.m. in the morning. And then I was taken by surprise. At least if we create an opportunity, there is a taker within the campus. That's one thing that I'm really mesmerized. And then when it comes to the faculty and the staff, I think a stage will come where each one would be in a position to develop the products by themselves. We are looking for opportunities to, as Nanda kindly coined, there could be a model where we operate. I was thinking we could go on the blended model where students take up their exercise on the day-to-day learning as an exercise to use the Fab Lab. And there could be a sourcing of the takers and the services that we could render from the Fab Lab by using the students and the faculty who are there in the college, and also making use of the community who really have the passion to create so that we could co-create along with them. So these are some of the things that are in pipeline. And then we are optimistic that we would be achieving most of the things that we dreamt, and then we had to dream for that. And then we
have a wonderful time talking to these young people and learning what they wanted to do. And when some friends were just loitering around, we just said, oh, come here, we'll show you how to use Tinkercad. And then they were really happy to learn that Tinkercad was quite easy. And within that hour, they were able to design a box or something for themselves. And they said that they'll come back and 3D print that. So after that, we also had the students from Aurora Academy of Health Sciences come over to the Fab Lab, and and develop their projects there. And of course, we needed to help them because they had just been there once for the orientation. So we had to help them develop their projects too. And Mr. Yamada and Tenzin were always there to help them. And also our student management team, who are very kind enough to offer their help whenever they are free, when they don't have classes. Just to say out loud, we have many students, but we have currently appointed 4 students as the student management team for the Fab Lab CST. So they really help us during all of the trainings for the schools as well as the students of CST. So I'll stop there. Thank you.
Thank you, Karma. Actually, it's quite amazing how you're actually doing the outreach to the communities, because in many actually Fab Lab in another, other countries, it's not easy actually for the school Fab Lab to open up the community, because they actually have some sort of ideas of schools for the school students. But you have been successfully actually doing this. And I think this is partly due to the Dr. Chekis, basically because school actually management, if they are not open, it's sometimes very difficult to open school for Sunday. Yes, holidays, but thanks to that. But Tenji Dorj, but you were actually complaining to me that students sometimes are very over enthusiastic about the use of Fab Lab CST. Can you tell us, about some of the challenges that you faced, as a technical lead, while actually serving the students and also the community at large?
I'm really sorry about that earlier. I don't know whether I get bit so excited or a bit nervous coming in front of you. Maybe this is my emotion attached with the Fab Lab for a long time. Actually, in order to start, I was there in the first Fab Lab. I started being a Fab Lab from 2017, and we were really struggling to bring the Fab Lab in our community. And now we are seeing so many things happening here in Bhutan, and a very big conference going on here because of all the seed we have sown so early. And maybe there's the attachment I'm still having. Which I cannot speak in front of you, and I'm still having a bit hard time to open in front of you all. And with the bit of struggling and with the challenges being in a Fab Lab in the earlier Fab Lab Bhutan, I have to leave the Fab Lab and I have to go on looking for the other job. But this Fab Lab never leave me behind. I went to CSC, College of Science and Technology, and now there is Fab Lab which hold me to be there. And this is a real privilege for me, and I'm now working as a technical and focal person of the Fab Lab, and I'm really happy that we are able to help many society being in a Fab Lab, and this was our vision to help and enhance the technology in our country, which is really behind for a long time. I still remember that during my school, around 11th grade, when there is a national Olympiad, the winner is those who made excavator with the syringe plunger, which can just move their limbs. And that was the open, I think that was the open topic challenge they did. And now, earlier we have just given a very specific topic where students have to build their project with a specific topic, and you have seen around they have really built a awesome project within a few days. And this is the product of Fab Lab, and this is the success of the Fab Lab in our Bhutan, which is really visible now. Going to the question for us, the challenge we face as a Fab Lab in our country is really new. And in order to let other people understand what is Fab Lab and how Fab Lab function is really difficult to explain to them. We say that Fab Lab is free for the community, and we Bhutanese really tend to take it as a really free, and which give us very complicated to explain when we have to take fees and everything. Even in our college, I'm having really hard time to convince my staff. Now, I think with going around a year, I think now students are more understanding about the Fab Lab and how it is functioning and how it have to go on with the self-sustaining. About these challenges, I'm also facing some challenge with the timing, and I said I'm also having my regular job as a lab technician, where I have to take care of the other lab, and I have to really sacrifice my time being in the fab lab and helping other students do their project, what they like. And even on the Sunday, sometimes they used to call me and I have to be like, oh, I also need some of my family times. This is a really hard for me, but this is the best I can do. And I'm sacrificing a lot for a fab lab, and I'm really happy that I'm able to do all these things. I'm not taking this as a challenge for me, but I'm taking it as an opportunity for me, and I'm trying to be the best for them. And I'm really trying to make Fab Lab however it wants to go. And I really like to make impact around my society. And I'm really grateful with the Fab Lab CST now. With the Fab Lab CST, I think we are making a great impact, as already pointed out by my madam here. And we are really grateful for having Fab Lab in our college.
Thank you, George. I can see the commitment here, right? I think the commitment of the Fab Lab CST team and also the CST in general, I think that is one of the key sort of lesson learned of the best example of the CST Fab Lab, I guess. So Wanda, I think you organize a community sort of lab, management team, right? That you have been, like Karma was actually mentioning about the sort of student sort of management unit. Oh, you're not a part of it, okay. Oh, the manager down there. Okay, all right, sorry about that. But from the former student's perspective, how do you think that you can contribute to make sure that Fab Lab CST is going to be more successful?
I know that I have recently graduated, and I also feel sad that I am not getting to enjoy the facilities of FabLab CST. But in the 1 year, in the 11 months that, or I think I've used around 10 months, but in that time, I feel really happy to have gotten the chance to apply my skills and experience that I got before the Fab Lab was inaugurated. So in terms now that I have graduated, I'm currently searching for currently trying to find a career, trying to develop my career. But I feel that since Fab Lab CST being located in Phinsiling, we do have to travel a lot to Phinsiling, and I feel that whenever I get the chance, whenever possible, that I will try to cultivate, that I will try to find some kind of training or workshop that I can give to the students. So I feel like firstly to get trained myself, and then I'll try to as Sir Nanda did in the previous years. So I would also like to do something like that for the Fab Lab CST. And also, like, I think some challenges that student faced were like being engineering college, the syllabus is much more vast, and then there are so many assignments, case studies, research work, and other so many time consuming like work that actually I saw that stops the students that stops the students from using the Fab Lab more. So but still some like the current students here and the student management team, they're still trying their best and trying to find the time. They're trying to manage the time and then get trained. So I feel like maybe college could also look into that and then make the students more, encourage students to use the Fab Lab even more. But I think now I have seen that more and more students are using, like in the younger batches, the new students, or the students that the new batches of students, they're using the Fab Lab even more. They're more aware of it. So I think maybe because we were exposed to it later, so maybe we didn't use much. But I think now more and more students will become aware of it, and I think maybe That's one of the things.
Thank you, Banda. I think the key to make it sustainable, I think, is how you're going to actually involve the students, both for the technical but also management perspective as well. So I think sustainability is one of the key, actually, thing that needs all Fab Lab, actually, not only the CST Fab Lab, all Fab Lab in the world, actually, the sustainability is the key word. So Nanda, from the sustainability perspective, you actually given us few example. But how do you think the Fab Lab CST should actually take? What kind of course of sustainability that Fab Lab CST might be able to take to make it sustainable, but not only sustainable, but flourishing?
Thank you, sir. Sorry for the earlier talk. Since I was very overloaded because we had a lot of stories to share actually. Because since it started from 2017 in Bhutan, and then I know that some of the audience here might be wondering, oh, Fab Lab was there. Oh yeah, is it the Fab Lab? What is that Fab Lab Bhutan? No, because it's not mentioned anywhere, right? So that's why I was very much very nervous. At the same time, I was very overloaded. What to share, in where to start and where to end. I was very much overloaded. So so coming to your point, I think here through my experience and then the availability of the materials here in Bhutan, and then looking at the protocols from the higher agency like governments and all, the base I can see is doing a reverse engineering. Reverse engineering, I saw a very opportunity here in Bhutan. Like not only the CST Fab Lab, all the Fab Lab. Like basic example I can give you is there is one innovation center from Nepal. So it's called a National Innovation Center, led by Dr. Mahavir Pun. He's a Nepali scientist, and he did that thing as a reverse engineering. And if you just search in the Facebook or any social media, you will find, and then looking at his work done, and then relating to our experience, it was quite very, very, if we can see that it's very beneficial, and then very, very, very related to our hearing, to this context, our Bhutanese context. So which means that reverse engineering, which means you can see many in our local areas, just some of the devices just lying, it's there, and they say that there is no expertise here, and we have to hire from somewhere. So the Fab Lab would be a based platform where they can recreate that, where they can do some analysis on that, where they can improve that. That would be that's what I see in Bhutan for the sustainability. So reverse engineering, I see a lot of opportunity here in Bhutan. That's one.
Thank you, Nanda. Yes. Now I would like to open up the floor. It's not fair that I'm the only one who's asking questions, right? So I would like to open up the floor first. And I actually understand that there is also a question from online, actually. Should we actually do the online question first?
Let's start with that, and then just let me know if you have a question. Raise your hand, and I'll come pass you the mic. We'll start with this one from a participant online. Are there ongoing research efforts in the Fab Lab focused on improving construction-related technologies, materials, or processes, and how do they benefit the local construction system? Should I read it one more time?
Yeah, I got the question.
Okay.
Thank you. Thank you, whoever has asked the question online. I think this is a passion that's deep in my heart. We are exploring currently. If I directly answer the question, currently no. We don't have the research that is taking place onto the construction material. But on the hindsight, we had been exploring many opportunities to see the possibility of using timber as a construction material, using ramnut as a construction material, using bamboo as a construction material. Works are underway, and then we have not reached that particular stage, but plans are underway, and then we have the expertise in-house within the college. So thank you, whoever has asked question. We would be exploring, and then if you are willing to collaborate, our doors are open. Thank you.
much, Dr. Cheki. I think you're a civil engineer by trade, right?
Yes, I'm
so
a civil
it's actually this is basically what you're waiting for, right? As in your heart. Any other questions from the audience, please? Okay.
Hi, I'm Andre. I actually spent there a week during the challenge, but I was so busy that I forgot to ask some basic questions. What I'm interested in is the Fab Lab right now integrated in the curriculum somehow, or it's pretty new, so maybe it's not yet, or are there some plans how to integrate it in the curriculum, maybe with like assignments, or that would encourage or require the students to use the Fab Lab?
I think it's a honor and privilege. I will take the most of the questions. I will leave some part to supplement by the manager. When it comes to the implementation of the curriculum, I think the one of the outcome for instituting the Fab Lab at CST was how do you make best use of the Fab Lab, which is attached to the engineering college. So that was one key questions. And then what we did along the journey was how do we integrate, as you rightly mentioned. So what we have done is there were many sessions led by Madam Karma and the team to integrate the curriculum which are more relevant towards Fab Lab. And then those tuning of the curriculum to take the practical classes, and then how do we design mini projects are already there. Apart from this, we see greater involvement of the college in totality through the involvement of faculties and other programs. EC, ICE, and then other related programs directly get connected to Fab Lab CST. But there are other there are other programs like civil and then architecture, where lots of other model making is also there. So they are also getting involved in that. So if direct to answer that particular question is taken care, and then we had already done that particular task. So do you like to supplement?
Thank you, sir, for this opportunity. And thank you, Andre, for the question. It was a pleasure to host you, and we had so much fun. First of all, I think we have already integrated in the curriculum, especially because the Fab Lab is under the Electronics and Communication Engineering Department. We have a module under the EC department, and our head of the department is here, Mr. Kamal. He's sitting down there, and he has also, yeah, he's there. He's also a Fab academic graduate. And he with Tenzin, they have also made use of the Fab Lab in that particular module. Besides that, we also had another Fab academic graduate who has recently left CST. He integrated this use of Fab Lab in developing models in the architecture, one of the modules in the architecture program. Besides that, all the final year project project work, they have used the Fab Lab, and that goes over all the programs which is present in the College of Science and Technology. And besides this official curriculum, I have two clubs that I coordinate, and one of my club, the CST Radio Club, we have a fashion show every year. Please don't expect too much. It's a very simple fashion show that in our local communities, just to let the students express and have fun. So that's how I introduced the fashion show with my club. So during that time, with the help of Mr. Koji Yamada, we made the students use the my favorite part of the Fab Lab, that is the digital embroidery machine and the sewing machine in the lab. And thankfully, Mr. Yamada has also sponsored that. So we had a lot of users during that time. And like Tenzin said, you know the rush at the end. The students come from all over the program at the last minute, and we had to keep it open, stay awake with them for the last few days. So, so in that way, we have been accommodating Fab Lab in the curriculum as well as in co-curricular activities. Thank you.
Thank you, Karma, and thank you, Dr. Cheki. Any other questions? I think this is actually a very, very good opportunity for you to ask questions. Anyone? Please? Actually, yes.
Thanks for today's session. I'm Imoto from JICA Bhutan office, and this is a question for Mr. Tenjin. So this 1 year, you have supported a lot of students to make a product by favorable machine. What is the most memorable product you supported? Please let me know.
Thank you very much for the question. Usually there are many products and many projects done in a Fab Lab, starting from the drone drawn from the top to the dustbin at the base. And from all that one, I'm really having in my mind that student, they also made some altar for Diwali, for the celebration for Diwali from the southern Bhutanese. They really made this one really beautiful, and by that time I was not in the Fab Lab, and I was attending Bali Fab Fest during that time, and I was not there. I really like that project because I was not there, and I was only the technical person who can operate the machine during that time, and it was really having a hard time for them. And I'm really proud that they could do that in a week, and they learn a lot. They learn a lot in my absence. If I was there, they wouldn't have learned that much. And with the struggle and with the others' help, they really learn much, and they really created a beautiful one. And that was my that project really is in my heart, and it's still standing there. But though it still needs some finishing touch up, but on the basis of how much they learn, that project is my favorite one. Still having in my heart from Princeton Fab Lab. Now there are many other fancy things students did from the Fab Lab CST. They even made some satellite. CanSat, right? CanSat. He was also there for this one, and I think two teams from CST. One is winner and one is runner-up. I think there are many winners from the CST during that CanSat competition, and I'm really proud that they made use of Fab Lab, and this product they are indirectly or directly from the Fab Lab. Thank you. Thank you for the question.
Thank you, Tenji Doris. I'm sure that there are going to be many more, innovations which is actually coming out of CST in the future. Can I ask you more questions from the audience? No? Are you sure? It's going once, going twice? No? Okay. All right. So I would like to actually ask them one by one, maybe 1 minute each. How do you see the future of CST in 10 years' time? Dr. Sheki, what do you think? Where is the Fab Lab CST is going to be in 10 years?
Thank you. This is one question that I had been aspiring and dreaming for to reach that particular goal. What we see is, number one, I know we are 6th Fab Lab in the country, and then there are many Fab Labs that would be coming in. So what I wish and aspire is there is an umbrella who coordinate all the Fab activities in Bhutan, which I would like to put a proposal to the Super Fab Lab here, who would be the coordinating unit down the line. I hope so. So that's one activity that we thought that there could be a cohesive way of integrating. The next, among the Fab Labs, there would be many learning opportunities within the Fab community. So there should be a platform where CSC, if they give us an opportunity, we would be more than happy to provide that particular platform to share the best practices of that many Fab Labs that is coming in. That's one. Then I know as we wish and our ambition grows, there would be many things, but we will keep things open. And then we are exploring ways to, now as somebody already said, I hope I will go one more than a minute. So what I wish and hope is there are many best practices the student does out of the main curriculum. How do we give this particular credit to the main curriculum is one thing that I had been discussing with the professors from abroad. I have also talked with Professor Neil yesterday in length. How could you all fill those type of activities as Nanda coined? And then some student like Wanda coined, how do we give the activities that is taken care in the Fab Lab not getting rewarded in a form of a credit when they could do wonderful things in the Fab Lab community? So from that angle also, I see that this could be in the making, and a vibrant, wherever there is an empty space, we are even thinking of, because I know classes, some free hours would be obviously be there. How do we bring in those vacant space filled up by other communities is also being explored. So a vibrant CSC Fab Lab with whom students and faculty interact and then they co-create things is a wish and a dream that I would like to see CSC Fab Lab taking as a journey. Thank you.
Thank you, Dr. Sheki. So, please, Karma.
Thank you, sir. First, I would like to add that we had also tried a little bit of commercial services. This kicked off with the help of our another FAB academic graduate, which I forgot to introduce, our research officer, Ms. Sonam Dikki. She's also sitting right down there. So I just want to introduce her too. And so we also tried a bit of commercial services, meaning we had, some laser cut mementos or logos put on some jackets and also something like that. Anyways, looking into the future, we have had a little bit of skill development in our labs, which we are confident of. And some of the things were already there in the project terms and the actions. And with the help of the challenge, where we had wonderful people with us working through, we are now looking really positive towards kind of branding ourselves into some services, which could be product-based, training-based, or education-based. So we are looking into this, and we are really positive. Our challengers have become like a small family for us, and I hope they will stay connected and work with us. So I'm looking at Andre here, because he's here, and I think there was Takemura sir. We have also Hamanaka and Ma'am Sonoko is also here. So everybody's here. So I'm hoping that, because we have discussed a lot of projects and we know that for sustainability, as you all know, this is a JICA-based project, and Mr. Koji Yamada is going to leave us in December, and we are really worried. It looks as if we are, we'll be seeing off our father. I'm sorry, he's too young to be my father, but still, I just always tease him. I say, you are just like my father, and I'll be very sad when you leave. So please give me some pocket money. Okay, jokes apart. So we're really worried about the sustainability, and we are looking forward. And this FAB23 challenge and the conference has really been helpful. And I'm trying to, connect to people, whoever I talk to, and they are saying yes. Even from Peru, they want to work with us, and from Andre, again, I'm looking at him, and everyone else who I have known. We are looking forward, and we have kept a little bit of ideas which we are going to ideate, and also the objectives that has been put forward during the challenge. There are 9 beautiful objectives, and I hope we win tomorrow. Even if we don't, I think we can still work hard towards making Fab Lab CST vibrant, and looking forward to a lot of mini projects coming into our Fab Lab, and also branding ourselves into, based on the skills that we have developed over 11 months, and more to develop in the future. Thank you very much.
Thank you, Karma. We can see how passionate they are, right? They're going more than a minute, all of them. But Tenjin Dorish, it's okay. You can go a little bit more than 1 minute.
From the technical perspective, I'm just not thinking to expand the lab, but expand the effect of the Fab Lab and Fab Lab to my society, and not only the society. I'm also looking to motivate the other Fab Lab to bring bigger impact on other society and all over the Bhutan through the. We really wanted to bring the technological improvement in our country, which is really behind for now compared with other country. I'm really looking forward to make these ripples go beyond our border, and I'm really looking forward expanding of the Fab Lab and increasing the number of the Fab Lab machines doesn't make any impact on the society. But the thing we do for the society, I think this is really going to make the difference in the country as a whole. I'm really looking forward to make the great difference within a few years. Due to the Fab Lab in our countries and Fab Lab in Fab Lab in the CST. First, we are just giving the impact to our student, and student as a whole, they will go into the society, and I think their knowledge and what they have gained through the Fab Lab, I think we are really expecting that they can make the ripple, which really brings the improvement in our technology in this country. Thank you.
Thank you, Tenji Dorish. Mangila, please.
I remember the first time that I created, and I remember the emotion that I felt when I saw my idea coming into reality. So, and over the time, I have also facilitated some, assisted in some workshops, and then I saw the young children that are that are designing and making their own design. I saw their faces light up when they see see physically what they made. So in future, I hope to see CST Fab Lab encouraging even more youngsters to take up such kind of designing and keep up their passion and say from a young age that they want to they want to make prototype, that they want to make some helpful devices. I want to see, I hope to see that from a young age itself in a few years' time. And one thing is that CST being CST Fab Lab being located in a industrial estate area, like close to the industrial estate area, like Pasaka. So we have a lot of industries there. So I hope to see, like currently most of the industries are using all imported machines. So I hope to see like the industries taking more interest into developing their own prototypes, doing research work or experimental works in collaboration with Fab Lab to improve their production or quality of their products, goods and services. So I hope to see that as well. Thank you.
Thank you, Nanda. Nanda, please.
Looking at the progress of the Fab Lab CST over the past 11 months, I'm very optimistic. And then in about coming 10 years, I would like to hear that Fab Lab CST dominating all the southern part of the country. Yes, Fab Lab, wherever you go, Fab Lab CST was there, yeah? It's all going to solve. So that's what I am expecting. Thank you.
Thank you, Nanda. Please give a round of applause to our panelists. But before we close, you've been hearing one of the superheroes' name throughout this panelist. May I actually introduce Mr. Yamada Koji? He is really the brainchild, godfather, superhero. Please actually come, Yamada-san. Yamada-san, please actually come. Please come. Unexpected, of course. It's a surprise, of course. So this is a superhero. This is a brainchild. Whatever you call it, this is the father of not only the CST, but the Fab Lab in Bhutan. Yamada-san, can you give us a word of wisdom? Maybe one word of wisdom?
I think for most of you who remained in this hall, attended yesterday's the first morning session, and in the last statement I made was a word I coined from Professor Niels, and just for the people who were not in the morning session yesterday, I would like to reiterate the same phrases. As a community lab, we are supposed to work for the achievement of the gross local happiness, GLH. So we would like to work for the achievement of the happiness of the southwestern part of Bhutan. Of course, Nanda already said that we have to cover the whole south regions. So we would like to work together to improve the happiness of the southern area. And after 5 years, we would like to see to what extent the Dzongkak-wise GNH index will be improved. So for that, we would like to work together. And no matter if I leave the Fab Lab CST, I would like to stay connected and see how they have been developing their own Fab Lab. So having said that, I would like to conclude my statement.
So sorry for the surprise, Yamada-san, but please stay on. Thank you so much, actually, for staying up with so late. This is the last session, I understand. Have a great evening. Can you actually have another round of applause for these wonderful people who are committed?
Big round of applause. Thank you. What an incredible amount of work you've done in less than 1 year. I can't wait to see what happens in 10 years. Thank you to JICA. Thank you to Fab Lab CST. One more huge round of applause for all these folks.